Okay. Oh, hey, Rush. I get kids 5 more minutes, looks like. Let me get attendance set up. All right. Late timer. Oh, everybody's super late. Okay. Seems like everybody had a rough weekend. All right, we'll just start whenever somebody arrives. Hey, Rush, you know if there's any things they have going on that students may be engaged with?
What you mean, like, you mean like for like events or?
Either or, like star testing.
He had all black legs.
Oh, there's Tamia. Never mind.
So I didn't even know that was a man. Girls don't go to
Tamia.
eyebrows all the time.
Tamia.
No, they don't.
Tamia.
Huh?
Can you mute yourself? There's your camera, but I was gonna say mute yourself. You got a lot of background noise. Good morning. Okay. So, all right. Well, let's see here. I got to go back and mark her present. Yeah, that's what I was asking, Rush. Are some students today taking STAR testing? That's what I was wondering, or things like that.
If they are, I don't know about it because I haven't done none today. But
Okay.
I'm not
Okay.
saying like Stonewall Irvin. I'm not grabbing people. They might be grabbing people, but I don't know.
Right. No, I just wanted to do the attendance correctly, but all right. Okay.
Oh,
All right. So I'm gonna work with Tamia, and then I got a feeling more gonna come in a second. I'm sitting there grading papers. All right. Oh, there's Stevenson. I kind of got the hang of this with these students. There's Carter. So everybody had a rough weekend. Okay. They made it though. Class starts at 12:20. Everyone. All right. So Lee Carter's here. Everybody's running a little bit late. Yeah, that's why I was asking that question because I didn't get a list of which students
hey,
are taking the STAR test and none of that stuff. So I didn't know what to
hey,
think.
Marianne.
What's
Stevenson,
up? What up, Russ?
Hey,
there,
what's up, man? Hey, you did any behind the scenes stuff today, like any star tests or any other things?
Now that I know of, was I supposed to?
No. I was just wondering. So yeah, probably not, Tyler.
okay. No, yeah, I know. They mentioned it last week. I just wasn't sure.
I'm gonna
Uh,
check my messages though, Mr. Rush.
I'm all right. No, I mean you probably all right. You know, what I mean somebody probably would have called you, if anything.
yeah. Okay, so
Alright,
Lee
yeah.
Carter's here. Stevenson's here. Tamia's here. I'm trying to see who else. Okay, so that's pretty much it. I can share the office, right? Yep. All right, we're gonna go through our norms, and then I'm gonna discuss today's problem so you guys can turn it in and get credit. But you also have a homework problem that's very similar. All right. I think today we're going to start utilizing our simulations once more. So to do that, we're going to use the Google slide deck. Simulations, we took snapshots, and the simulations are also to help you guys visualize what's occurring in real time, because not everybody learns from just reading or doing the math. Some people need to visually see what's happening. Today's objective is here, and so is the term and the word of the day. Those are your exoslip components. So if you need me to put this slide back up, I can. Let me move this out the way because we got to do our norms. I'm trying to save it to the office. Okay, here we go. 5. So we got 10 norms to do. We're going to go down a list. Some of you guys have to read at least 2 at a time because we got a lot to cover today. So starting with Mr. Carter, can you read number 1 and number 2 from the 5 basic norms? Lee Carter, are you there? I see his camera's on, but I'm looking.
Yeah, you are calm.
Yes, he said I call. Yeah, can you read number 1 and number 2, sir?
No one has the right to hurt another person. Education classroom sick.
Thank you, sir. So coming up next would be Stevenson, number 3 and number 4 on the screen.
We will never behave in a way that will discredit ourselves, our school, and our family. At Excel Academy Southwest, students always elated with genuine.
Thank you, sir. All right, so coming down to Tamia, I'll read number 5. We take pride in Excel Academy Southwest. I hope you all do. Let's see here. The 5 academic norms. Tamia, can you read number 1 and number 2?
We respect the opinions of others. We respect the culture of the classroom.
Thank you, Ms. Love. Coming back to Mr. Carter, can you read 3 and 4?
We are attentive and participate. We have high expectations of ourselves, our peers, and our teachers.
Thank you, sir. And lastly, that would be Mr. Stevenson, number 5.
We are here to focus on preparing ourselves for post-university.
Thank you. Okay, so let's see here. You guys got your points for that. All right, let's go into make sure you size your screens, everybody. So you should have, if hopefully you're on a computer, keep saying that, and not a cell phone or something like that, but resize your screens. If you are not on a computer or a desktop or something of that nature, you're going to have to download.
Mr. Tyler, excuse me, Mr. Tyler. Can I please turn my camera off right quick?
Yes, you can. See, that worked out quite nice, right? Okay, hello, David. Let me mark him present. I like how she asked that. It was all cordial. All right, let me go back. David Concepcion just made it. David, what's going on with your camera, sir? All I see is demons. It needed to be you and not a logo. Okay. So,
It's not working. I gotta refresh it.
okay. We'll work on it, please. Now, everybody log into your Gmail account that you're going to use. And this is how you get access to the Google apps. So you have to be logged into your appropriate Gmail that you're using, preferably when you're using for Google Meets, because that helps the connection, right? So also, if you're using Chrome, I have to tell students this all the time. Tamia raised her hand. Go ahead, Tamia.
I got Google Docs on my phone.
Okay, then you could follow along in class because you know I'm gonna have you share out, right? So you don't have to type it on your phone though. It's gonna be a little tough. Okay, that was your question, I guess. All right. Why did David leave? Oh, he said he's refreshing. He said he's probably coming back. All right. So anyway, what was I saying? We're in 3rd period. Y'all get me on track. We still got a lot to do. And you want to come down to today's assignment. So do that, but also simultaneously, if you're on phone, it's kind of difficult. You have to make sure you open up a Google Docs and have it open, because you're going to take information from EDSB and put it into your Google Doc like we do every day, right? So let's open up a blank document. And the first thing we're going to do is we're going to name the document, right? So let's do that. And we're going to call it due now, right? And today's date. So the 23rd, it's almost turkey time, huh? If you're doing that, or I don't know if you're vegan, but it's almost a break. I think we got 2 days, this day and tomorrow we're in class, and then everybody pretty much gonna have time to probably catch up with family. Not too many of them because COVID, and probably get some rest. If I were you, if I were your age, I'd be trying to finish up any assignments I'm missing during this time. So it's from Wednesday. So check my son's CPS calendar. It's from Wednesday to Friday. You're off. It's a lot of time to catch up on work if you're serious about it. Period. And this is third period, right? Intro to engineering students, or engineering with robotics. We say the technical name, with robotics. Please type it all correctly. And 15-point opportunity. I kind of slid it out the way as far as in ESI what it looks like. Who knows what today's title is? See if anybody can figure that out. You can raise your hand and answer, or I eventually will just type it in myself and the points will evaporate. So who knows what it means, what today's title is? I'm trying to see, make sure I took attendance correctly. Yeah, I did. Nobody knows? All right. So I'm gonna give you guys a moment or so before just type it in for you. It goes in the center. But the exit slip I showed on the screen a moment ago. So try to get in the habit of sharing.
Force field, electric field, something like that.
Carter, great job. Yes, sir. Very good, very good. 15 points awarded. So classroom terminated today is how you get your exit slip points. Now, a lot of students are not typing in the definition. I don't know what they are thinking about, but if you just give me back exit slip, classroom terminated today, like I'm typing, like this, and you just put the word there, but you don't look up the definition. That's these, like a lot of these terms, you guys and gals, are for SAT preparation. So you have a rich vocabulary for when you take that test, and I think that's a graduation requirement as well for some of y'all. All right, so word of the day is, now what are those? I showed you a moment ago. I think if you were in Townhouse GGI, it was substantial, right? And the classroom term of the day, I think, is electric force. I think Carter said it for us, right? Let's go here. So yeah, you see it in brackets, electric force. That's where he got it from. So let's type that in here. So I'm showing you how to edit your document. So it's force field, like Star Wars. That's what I found amusing. But you guys are now moving into electricity, and that's why we got to look at some simulations to see what this is all about, right? So the term is in the brackets that you saw on ESB, and that's electric force. Okay, so electric force. And then enter. And this is the part where you put your two questions in there. Now, remember, both of these require definition. People are not putting the definitions in there. So you're not getting any of the points. You don't get points for copy and pasting. You get points for understanding, right? Comprehension. I say definition right there. That should like immediately tell you, put the definition there. All right, kind of do now, do it now. You know, you'll be like, why you put do now? Because I wanted you to do it now. Kind of redundant, eh? So let's take the two questions, and then we're going to talk about it in the chat. A few students can get a few points, depending upon who reads this. But let me first put this in the document so you'll know what you have to have so far, if you've been following along with me and paying attention. You should have these two questions. 1S is synchronous. That's in class, we do this together. 2A is pretty much asynchronous. You do that on your own before 8 p.m. tonight. Both have to be turned in. Some students are just turning in 1S and they're getting 50% credit. All right, that's on you. But you do have to try 2A because you can't learn it unless you try it. It's kind of like riding a bicycle. All right, so let's continue on. I think first I want to do is our simulation. So you kind of need the Google slide deck to do that because you had to click on the simulation and begin with me. So let me grab this for you. Put this in the chat. And this is something you should have already bookmarked because it's very helpful. All the simulations, as what we're doing, simulations or models, they'll still be on this slide deck. So what I want you to do is click on where are we at? I got to update second period, but you click on me. But make sure you click on the link in the chat to get here. And next, you click on the SPS logo. And this information is old here. I got to change it, but where is ours at here? So I think if we click on what's the one I wanted, the Duracell battery. I think that's the one we talked about charges. So you might want to click on advanced because you got to do a simulation. Yes, to me. You raise your hand. What's going on?
Okay, this is my last time turning my camera off. Okay.
Oh, okay. All right. So everybody clicked on that link that I got to. Make sure you did what I did. You went to the classroom and you clicked on the battery, and it's a little battery in the cubby hole there, and it allows you to get this simulation going. So you need the simulation started. I probably should just put the link in the chat for you all so you can see that. But overall, let's see here. It's almost initialized. Okay, yeah. So this is what I wanted you to immediately click on that link so you can have it open, because we're going to grab a simulation and we're going to put it into our calculation. It's 1242, so we got a lot to do. Okay, so you'll see this eventually. And what I wanted you to understand is how the electric field works in the system. You're going to take a snapshot. This is usually a tough part for everybody because you're taking a snapshot or screenshot. Some students, I don't know, you're using a phone, you got to, do a screen share or screen snapshot. I don't know what you're using, iPhone or Android, but you got to try to figure out how to screenshot it to put it in your document. So here's what you need to screenshot. First, we got to, show the representation of the battery. Now, on one side, we have things called charges, right? And the same thing for the other side, but they have a polarity, so plus and minus factor. I'm going to get adjusted for a little battery voltage, and you'll eventually see these potentials come over and grab these charges. Now, these potentials, they work like force vectors, right? And they're bringing it over to the side, and this is essentially what happens anytime you plug something into a battery into a system. They're going and they're going and they're going to keep exchanging these charges from one side of the battery to the other. Okay, so this is what we're going to be talking about essentially in our first calculation. So let's take a screenshot of this and blow it up a little bit. And to screenshot, you hit PRTSC if you have that on your keyboard, or you could try to download it, the image of this. Either way, you need this first picture. So I just gave it about, a little bit of voltage to one side, and it's grabbing charges. So I hit the print screen button. And now all I'm going to do is come back to my Google document, and I'm going to put that print screenshot into my document. So come here. Let's bring this up a little bit so you all can see that. And code control, press V, and my image is there. So now I got to crop it. I'll be telling you guys about this all the time. I'm going to crop an image. All right. When you crop it, you're taking the data and just chopping out what you don't want. So you grab the black bar, come here, and come here. This is what you should be doing right now, and making sure you got that image from the simulation. Okay. So once I do that, I click outside the image, and I've chopped out what I don't want. It'll let me just keep that image. So now I'm gonna put that in my document. Just stretch out a little bit so we can see everything. Everybody get ready for doing our problem. Now it's 12:45. We got here 1:20. We got a nice amount of time to finish this problem off, but you need to have that simulation picture in your document first. So let me go back to the simulation and put the link in there in case you didn't get to the link. Because the first one was a slide deck. Now you need the picture that I just gave you. Let's put this back in here for you. And if you click on it, it takes a little bit of time to load, but that's what I was telling you in advance. Load it now. So click on that link, open up the simulation. Like I said, show the battery, give it some desired voltage. Then take a snapshot or a screenshot of this picture and put it into this document. Okay. So let me get your notes ready for, I'll give you about 3 minutes to catch up, and then we're going to do our notes for this problem. Okay, so just to recap, if we minimize this, what do we have? So let's take a look what you should have so far. We got our document named, right? We have the header, we have the title, and we should have our exit slip and ready to put the definitions in there. Okay. So the questions 1S and 2S are there. Let's see if Mr. Carter, can you read what's in the chat? I just put the 1S question in there, synchronous problem there. It's for 35 points. Mr. Carter, are you there? His camera's off. All right. Let's see here. Tamia, can you read what's in the chat? Miss Love, are you there? Okay, she seems preoccupied. What about Mr. Stevenson? Can you read what's in the chat? wants the points. Okay, so basically, the problem is in a certain region of space, a uniform electric field has a magnitude of 4.6 times 10 to the fourth newtons per coulombs and points in the positive x direction. Right now, it's the x-axis we're talking about. Find the magnitude, and you can consider this x-axis coming across this battery. So find the magnitude and the direction of this force, the force this field exerts on a charge of A plus 2.80 microcoulombs and B negative 9.30 microcoulombs. And here's again with prefixes. You have to find out what micro means, and that's 10 to what power. So to begin this, we want to take a look at the definition for the magnitude of the electric field, and that's going to be E. Well, electric field, let's just spell it out in English, right? Is equivalent to, what is it, force on positive charge, or point charge or positive charge. I know what Google was trying to say. So positive charge, and that's going to be divided. This is all one element, like right here, divided by the amount of charge. So put in parentheses, amount of charge. Consider this, and then come down the line. Now, what does that mean? Well, what I mean by that is, how is it measured? So electric field is always measured in terms of a force. So, and then that force is newtons coulombs. That's why I said it's a force, but it's newtons per coulomb. So to measure its dimension, I'm sorry. Okay, good. I gotta turn that ringer off. So to measure its dimensions, it's always a newton per coulomb. All right. And that's going to be equal to the force on a positive charge, and that's simply measured in newtons, right? So you're going to put Newton there in parentheses, and that's what the force is. And lastly, divided by the amount of charge, which is pretty much coulombs. That makes sense, and it should, because you see it correlates to the same, what it's equivalent to. It's a capital N, so it looks just the same. All right, so now we can write that mathematically as what? Well, we can say E, as shorthand for electric field, is equivalent to the F for shorthand of force, being that's what force means. Just put these in parentheses, so when we insert things, we'll already be ready. Okay, and divided by, this is called Q naught, so it's lowercase q. You put a 0 there, but you got to subscript the 0 because it's Q naught, meaning initial value of charge. All right, so that's how it's supposed to look. Make sure you edit the same. Yes, I'll put the notes in the chat so you guys can catch up. And then, as long as we have this, we're good. But then there's another representation for just the electric force, right? So this definition here is the magnitude. This is what we call the magnitude. Let me come to the center of, or the definition, I should say, of the magnitude of the electric field. We call E in this case.
Mr. Tyler,
Yes.
when we get out of school for Thanksgiving? Tomorrow, right?
We're out from Wednesday to Thursday, Friday.
So we get out Tuesday?
We get out. We come to school Tuesday tomorrow. Yes, but we're
Okay.
off from Wednesday to Friday. To me, yeah. I was like, she was throwing me off. Yes, we're off from Wednesday to Friday. I think I'm saying that right. Okay, so what was I saying? Then come here, and there's another way to write this, and this is the algebraic way when you guys are trying to solve for certain things. So in this case, you're solving for electric field, but you need another definition to solve for just the force, and that's the problem here is asking. So you got a little more notes to do. So what is this? This is the definition here, or this is the representation, I should say. So the representation of the electric force due to an electric field. This is very powerful when you're talking about robotics, you're talking about anything electrical engineering, even just electricity, period. Because it's, lets you understand why Newton's second law is so important. F equals ma. We talked about this a long time ago with work and energy and power. Well, now we're looking at electricity as a form of that. So how do we rewrite that? Well, it's going to be an algebraic calculation, but just for the sake of time, we're just going to put out the definition. So now it'll be simply force, in this case, in terms of our electric force, is going to be the amount equal to the amount of charge, the parentheses around these, and that's because they had to be multiplied. So multiplied by the amount of charge, right, times the electric field. It's just the same equation, but that's what algebra done on it. Hope you understand. It's nothing new, but this is like, with the algebra already completed. But you got to rearrange the above equation to solve for force. We still got some form of F equals ma, mass times acceleration. All right, so no, I do not want to listen to the radio. Stop that. So I'm going to come down here, and these things are measured the same way. You have the new representation of what they're measured in. You have force is measured in newtons. Which is going to be equal to the amount of charge is measured in coulombs, right? Times electric field. If you come up here, it was a Newton Coulomb, right? So you see here Newton Coulomb for the electric field overall. So it's going to be this one. And all I'm saying is these two equations are the same equation, but just, really rearranged using your math skills or algebra skills. So put that here. And that's how that looks, right? Without that extra parenthesis. All right, equation you can use for it, mathematical representation, shorthand as I call it, is F equals, well, we have to say amount of charge, right? So amount of charge is usually that Q naught. Come back and grab that. This was this here we talked about a moment ago. Grab that. That's your amount of charge. And then amount of charge is multiplied by, or Q naught is multiplied by, let's turn this off for a second. What? Well, that's the E field, so that's the E right here. Okay. There we go. Just put some parentheses around this joker so it looks the same. And now the next step is we're going to put our known and unknown values in and finish the problem off. And it's really easy to do. I'm going to do the first part with you. And the second part I want you to try. Let me turn this off real quick. There we go. So parentheses, come here, parentheses. So that's what I want it to look like for you. Okay, known and unknown values. Let's get this problem done with. What do we know and what don't we know? And I think it's a part A and a part B to this. Right, so going to the top, looking at our problem, and make sure you have your diagram in there too. This battery simulation, I gave you the link to get it, so make sure you take a snapshot so you can put it into your assignment. All right, so what's the first value? Well, we're going to look at the values they gave us. So electric field has a magnitude of 4.6. Now remember, I say again, the electric field, right? So that's E. We just talked about what that is. So it's newtons per coulombs. That's another thing. The measurement we just defined, I gave you the notes on it. That lets you know that's the E field. Okay, so we're going to say E, like this E like we talked about in this equation. So E is equivalent to that value we just got. We got to clean it up because it's got to be raised to a power. So it's 4.6 times 10 to the fourth newtons per coulombs, right? So I'm going to grab that. Let's put that in there. And I'm going to raise it to the fourth power. So I'm going to remove this and just say raise, because I want to show you how it's supposed to be written. That's taken straight from Edsby, but from here on out, you got to fix it so it looks like that. So that's actually going to be one of our first values. Our second value is what? Well, there's a part A and part B, so you do this calculation twice. So they say it exerts on a charge of, hint, hint, of microcoulombs. Only problem with this is you can't use microcoulombs. You have to use what it is in coulombs. So micro, if you look it up, it means 10 to some power. So let's put this here. This is going to be your Q naught. So we're going to grab that. And we're going to put that into our equation.
Mr. Tyler.
Yes, ma'am.
So when it say, wait, it's in the way, Mr. Tyler. So you multiplying 4 times 60 to the 4.60 times 10 to the fourth power.
Yeah, that's your one known value. That's E. Yeah. That answer your question? I guess it did. Okay. So what was the next value we had? This is going to be times some power too, right? Because this is coulombs and it's microcoulombs. So who knows what micro means? That's 10 to what power? This is positive, right? But if you don't know that positive there, we're going to take this again. You have to convert that to what? Well, it's not going to be micro. It's going to be times 10 to. If we look up micro, you'll find out it's a -6. Okay. So we're going to raise that to a -6 power. Now, just looking at what micro means, like kilo, micro, centa, they have they're called prefixes, and they mix to a certain power. Okay, so let's raise that. There we go. That looks better. So you got to use this value for your calculation in part A. Okay, this is all part A, by the way. It's the first value they gave you. You need a part A calculation for what? Well, you need one for force in part A. The force, right? Or F equal to some number in newtons. And you're also going to need to do it again because you need it for part B. It's a force in newtons. I'm going to do it on time. Okay, 17 more minutes of class left. Let me hurry up. You need it for part B. And let me put this in the chat so you guys can have it, because then we're running out of time. So I'm going to type up part B, but this is, you should have about as much as I got. And we probably might have to do share outs tomorrow. We still got a few more things, a few more steps to go. Take a look at that, but you got to edit the same way as my screen. And just put it in the chat for you guys to keep up. Okay, so what did I say? You have another value for, and this will be for, the same situation where you have a Q naught for part A, but it's going to be also, something you can't use is in micros. So you got to convert again. So let's come here. And this time around, I think it was a negative something in our question. Go up here and look. And yeah, it was like a negative 9.30. So I'm going to change that to negative 9.30. It's micro, but we can't use micro, right? So we got to do the same thing we did before. Grab this, and it actually converts to, for part B, you're using this. Right? So this was a minus 9.30. And it's going to be 10 to the -6 for micro. Yeah. Okay, so far so good. Now all we got to do is solve your strategy, but by the way, solve for the force in both parts, A and B, right? What does that look like? We're going to take this equation here, okay, just a small part, and we're going to do it twice. and it's absolute value for the charge. So don't worry about the plus or minus. Okay, so with that said, let's grab it, and you just plug the values in. Remember, you got to do it twice because you got one for A and then one for B. So what does that look like? Well, for us in the first one, we're using this equation, right? And let's do it for part A, and that would translate to, if we take this equation and come down one, to just taking Q naught in this first one, and that'll be this part. Now again, it's absolute value, so if it's negative or positive, it's going to be automatically fixed by the equation, being absolute value for the amount of charge. So that's the first part, and then you have the next one, which is the E value, right? We get this from our known values earlier. Now, newtons and coulombs are gonna, or newtons per coulombs, they're gonna cancel out the coulombs. So let's refix this. Then you're gonna have to do part B on your own and the homework problem, because I want you to have some time to practice this. So, like I said, coulombs and all this is gone. Newtons is gonna pop outside of the equation because it's gonna be left by itself once coulombs cancel. Then coulombs, let's see here. Okay, and what comes outside of this, like I said before, is your newtons. Coulombs canceled out. Coulomb divided by coulomb is 1. So we got what now? This equation up. Okay, so like I said, all this is gone. And then you're just going to have to use math pop, everybody, to finish this off. So you end up with this situation. And it's really easy to calculate in there. And like I said, this is absolute value. So this is really what you're going to plug in the math popper. Okay, and make sure you type it in correctly. So I'm going to show you how it looks, and I want you to calculate it because you got to do this one more time for part B. All these calculations are pretty much part A. Do it again for part B and edit the same way, all the same steps. So next time it's going to be not 2.8, it's going to be negative, or not even negative, it's just going to be absolute value of 9.3. Just put the number in there and calculate it out. So last steps, how do you calculate it out? I'm sure you're supposed to look at math pop in one moment. Question mark. We're going to calculate that. And that's you're going to be, I'm going to put this in the chat so you guys can do it, but then I'm also grab math pop in a second so you can finish up. So let's recap from here so you have all the notes you need. All right. That's the last round of them. Now to calculate that final answer. So if you come here and you type it in slowly, like I'm about to do, let's move this out the way and move that out the way so I can see it. Great. And scroll over. So let's type it in slowly. I'm going to get rid of all this jazz. And what do? Well, I'm going to put parentheses, division button, make a fraction, and let's type the first one in. Well, it's not division, it's a multiplication, my bad. So it's going to be what? I'm going to put parentheses, the first value, which was, what did I say, 2.80 times 10. You hold shift and press 6, it raises to a power, and it's -6, right? And press over key or directional key over, close parentheses, multiply by parentheses. I hope you guys are trying this out because you're going to do this with your part B and your homework problem. So you can do this like 3 times again with math pop to get the right answer. 4.6 times 10. We're going to raise that to a power, hold shift, press 6, and it's -6 again. Okay, so this is exactly the steps I gave you, right? I hit enter. And it's acting funky. It says 0. So what happened there? I got to use a different calculator or something. Let me see what's going on here. 4.6 times. Oh, it's to the 4. I see what happened there. That's what's wrong. It's not to the 6. I'm like, what happened? How do we get 0? 4. Is that what? There we go. I'm like, it's not 0. I did this last night. Okay, so the final answer in this case is 0.12. You can say 13 because that's just rounding at 2 to 3. Now that's part A. You got to go back and do the same steps for part B, everybody. Okay. In part B, you're just changing the values. Parentheses around that. I think I gave you all of that stuff, but don't forget you got part B. We got 9 minutes of class left. Does anyone feel confident enough to share out their work so far for in-class points? Or you just want to finish up getting the notes edited correctly from what you can see? Again, don't.
Tyler,
Go ahead.
I said give me like 5 minutes.
Okay. All right. Let me set the clock for 5 minutes, everybody. Just make sure you try out all the parts and don't forget about part B and the homework problem. You're literally doing the same thing, but in this section, let me just show you real quickly. In this section, it's not going to be plus 2.80, right? It's going to be pretty much the negative 9.30 times 10 to the negative 6 that you plug in for that next step. This value, 4.6 times 10 to the 4th newtons per coulombs, they stay the same. So you're going to recalculate it for a different charge or amount of charge. You got questions, man?
Yeah, I'm trying to show you what I got.
Oh, okay. You ready? Okay. Let me turn this on. Okay. Let me turn my presentation off. Go ahead, Tamia. Try to share. You're presenting. Cool. Okay. Now you gotta show. There we go. Okay, you got a lot done. All right. You're missing some of your header though. Okay. Scroll down a little bit. All right, that's
That's
as
it.
far as you got. Okay, so
Yeah.
try to get the rest in there, and then
Can
try to
you put
prompt.
it in the chat?
I did put it in the chat.
I don't
You see
see
it?
it. I don't see
Oh,
it.
okay, so I got to put it in there again. It looks like. Hold on. How about now?
I see it.
Okay. So I just did all the way down to what you can see on the screen, and you got to edit it the same way. So try to get the rest in there, and you still got to do part B. What are the next steps, right? So this is how part B would look, and you got to show me how you would work it out. Who said that? Stevenson? Oh, Lee, you want to share? Yeah, I see your hand, sir. So Tamia, you can stop sharing. You got your in-class points. Stevenson left. Oh, I was about to ask him next. Um, let's see here. I'm trying to see. Lee, are you about to present? I think. I can't see your screen yet. That's why. Oh, there you go. Looking good. Okay. Let's see. Look like you did part B as well. Yeah. Okay. Okay. Pretty good, dude. All right. Now, don't forget to do the homework problem now, everybody. That you do the same steps to with different numbers, set it up differently, correctly. Take your time with part B.
I can leave.
Let's see how much time we got left. Yes, you can. It's 5 minutes before we got to go. So I'll see you later. Tamia, you're free to go too. If you don't have any questions, please turn it in. She hung. She just left. Okay. All right.